What's up guys, welcome back to the channel. In this video tutorial we are going to discuss about the code implementation of a pre-order traversal. If you have not watched our previous videos, I request you to please watch the previous videos, go through the previous videos and then come to these videos. Otherwise you will understand nothing. So in the previous concepts we have understand what is the pre-order traversal, what is the post-order traversal and what is the in-order traversal actually is, and how we can calculate or how we can evaluate or find out the in-order, pre-order or post-order traversal for any given binary tree. So in this video tutorial we will be discussing the pre-order traversal code implementation, how actually the pre-order traversal works and how we can write the code for any binary tree to find out its pre-order traversal. So let us see. So we have already discussed how to create a binary tree and also discussed the code about how to implement a binary tree. In this video tutorial I am going to show you how we can simply find out the pre-order traversal and what is the code implementation for that particular one, and by the line by line of code I will explain everything about that particular thing. So let us suppose we are having a binary tree like this particular one. I am not taking a binary search tree, I am taking a simple binary tree. So let us create a simple binary tree here. Here I have a node 1, it having a, let's suppose, a left children 2 and let's say the right children of 1 is a 3 and the left children of 2 is a 4. The right children of a 2 is a 5 and the right children of a 3 is a 6. So we have already discussed how we can calculate its pre-order traversal. In case of a pre-order traversal, we know that the rule is pre means before. First of all we having a root. Clear? So first of all we having a root in case of a pre-order traversal I am talking about. Then we go to the left subtree. So I am writing here a left. And then we move to the right subtree. So I am writing here a right. So this is a very important thing you need to understand about the pre-order traversal. Whenever we are doing a pre-order traversal, you just need to follow these rules. First of all, we have to access the root. After accessing the root, move to the left subtree of the root. After accessing the left subtree, when the left part of the root is completed, for each and every node we are doing this concept recursively, and then we need to move to the right subtree. So if I talking about the current root, let's say I will start from the first node in this binary tree. So this is my first node, this is a current root. So simply add it to the answer. So I will add it 1 to the answer. So now the root part is completed. Now what I will do is I will simply move to the left part of this one. So what is in the left part of this one? There is a 2. So now 2 is a current root. So first of all we need to add a current root to our answer or in a traversal. So I will simply add 2 here. Now again for this particular 2 I have taken a root. Now I need to move it to its left part. So from the 2 I move to its left part. Now I am at I am at the node 4. So now the current root is a 4. So simply I will add it to the traversal. So I have added here, and now again I will move to its left part. As we know that it is a leaf node, and in the leaf nodes left and right field there is no node is present. So what will be present here? Here will be a null as well as here will be a null. So because there is a null, so what I will do is I will simply return back. So for this 4, the left part is taken, the root is taken, and now I need to move to the right part. So recursively I will go to its right part. Again in the right part I have nothing, I have a null. So simply what I will do, I will simply return to here. So for this particular 4, I have completed the pre-order traversal. Clear? Now what I need to do is I will simply return back to this 2, and for this particular 2 I have taken this 2 as well as this left subtree part. If you carefully see, I have taken the 2 as a root, its left part. Now I need to move to its right part. So I will go to its right part. In the right part, what is the current root? 5 is the current root. So simply add 5 to the answer or in the traversal. Again after adding current root in the traversal, I will move to its left subtree part. In the left subtree part again I having a null. So simply what I will do is, here is a terminating condition that whenever I will find a null, I will simply return. Obviously I know that there is nothing when there is a null. Okay, so I will simply return back to this 5. I have taken a 5, I have traversed its left part. Now I need to move to its right part. Again in the right part of a 5 there is nothing present. So what I will do, I will simply return back to this 5. So I come back to this 5. Okay, So for this particular 2, I have taken a 2, I have taken its left subtree part, also I have taken its right subtree part. So I can say that for this particular 2, the in-order traversal is completed. Now I can move back to the 1. If you carefully see, for the 1, I have taken 1 and then I have taken its left subtree part recursively, doing the same concept of root left and right. So root is taken, its left subtree is taken. Now I can move to its right subtree part. So from 1 I can move to this 3. When I move to this 3, if you carefully see, this is my current root. Simply I will add it to the traversal. So let's add it in the traversal. 3 is added to the traversal. After adding it to the traversal, I will move to the left part of the 3. So there is nothing present in the left part of a 3. So I will simply return back, and now for the 3, we have completed the left traversal, root 3 is taken. I can move to its right part. Again in the right part, if you carefully see, there is a current root as a 6. I will take 6 as a current root. Then I will move to its left subtree part. Again there is nothing is present, so I will simply return back here, and then I can move to its right subtree part. So only thing you need to remember is, for each and every node we are doing this concept again and again. So basically we are doing what? We are taking a root, then we are moving to its left subtree part, and when we move to its left subtree part, the current root, for the current root we will do the same step. We will move to its left subtree part, the current root, and then we will move to the right subtree part. And after all these, 1, 2, 4, 5, 3, 6 will be the pre-order traversal of our binary tree. So how we will do this recursively? So let us talk about how we will do this in a coding implementation. So before going to the code, make sure you have subscribed to our channel and also press the bell icon. So let us see the code part of this particular one. So guys, let us discuss the coding part of the preorder traversal. So let me change the color. So here, this is simplest function for the preorder traversal, which having a return type of void, means it will return nothing, and the name of this function I have taken as a preorder traversal, that is I am taking in a white. So what this function takes, so let us suppose, first of all let me create a binary tree. Quickly let me create a binary tree. So suppose we are having a binary tree something like this. Let's say this is my binary tree I am taking. Here I having a binary tree, if you can see. Okay. So let us suppose this is the binary tree given to me. Let's take a right child of a 3 as a 6 also. So what I need to do is I need to find the preorder traversal. So how this code works, let us see. So before moving to this coding part, I accept that you know the concept of a recursion. So here the recursively what we are doing is, let me explain. So recursively what we are doing is, first of all, if you carefully see here, I am calling a function for the 1. This is a preorder traversal function. When the preorder traversal function is called, what I am doing is, first of all in this function I am passing a root. Clear? So initially I will start from the 1. I have highlighted it with the yellow. So I will start with the 1. So when I start with the 1, this function is called. So I can say the function is called, sorry, let me take a pen again. So this function is called for a 1. I can take here. So this function is called for a 1. Clear? So my current root is a 1, because as you can see I am calling this function for a 1. So initially suppose I am calling this function for a 1. What I will do, let's ignore this base condition. For 2 minutes let's ignore this base condition of if root is equals to null. I will explain what this base condition is. So what I will do, first of all, simply whatever the root is, print its data. So what is the root's data? That's a 1. So 1 will be printed in the output. After that, preorder traversal function is recursively called. At this position you can see that, if I say at this position, you can carefully say that preorder traversal function is recursively called for root to left. So I can say that, you can say like for root, what is the current root? Current root is a 1. I have initially called this function for 1. So I will again call this function for 1 to left. What is in the 1 to left? I having a 2. So this function will be called for the 2. I can make another function call here. So again function is called for a 2. Clear? And again whenever the function is again called, again control comes inside this function, again a separate copy of this function will be created if you understand the recursion. So what will happens, again control comes inside, and if you carefully see that here at this particular line, what I have done is I have simply written print the root data. What is the current root? That is the 2. So I will simply print the current root to data. So let us print it in the output. Again recursively what will I do is, for this particular 2 I will call a function for its left. First I have taken 1, then I have printed 1 to data, and then I have called the function for its left, if you carefully see. So its left, and then 2 is printed, and now I will again call the function for its left. So 2 to left is what? 5. So again the recursive call goes to its left, and the function is called for the current root as a 5. So here the function will be called for a 5. Clear? After that again whenever the function call is created, every time a new copy of a will be created, function will be created. So again what will happens, the control comes inside. If you carefully see, what I have done is I will print the root to data. So here I have printed the root to data. What is the current root? That is the 5. So I will simply print the 5 here. After printing a 5 here, again I am calling this function recursively for the 5 to left. At this particular line I am calling recursively function for 5 to left. What is inside the 5 to left? There is nothing in the 5 to left. If you carefully see, 5 is a leaf node. Here I will get a null. Similarly here also I will get a null. So when I call this function recursively for 5 to left, here will be get a null. So again when I am calling this function for a null, when the root value is a null, if you carefully see here, let me explain. If you carefully see here, if root is equals to null, what is the meaning of this particular condition? It means that I am reached at that phase. So let me explain. I have reached that phase. So when I encounter a null, what I will do is I simply return. So when the control goes here, I will simply return back to this 5. When I simply return back to this 5, and for this particular 5 the left call is completed. Now here the right call will happen. So when the right call happens, the recursion will move to the right of the 5. So in the right of the 5 again I have a null. So when again this function called, this base condition, that is if root is equals to null becomes true, this base condition becomes true. Because this base condition becomes true, so whenever this base condition becomes true, I will simply return to the previous stack frame. So control goes to its left part also, and here also I will get a null. So due to which I will simply return back to this 5. So this is how this happens. So for this particular 2, if you carefully see, for this particular 2, I have taken its left recursion. I have completed its left recursive call. Now I have to do the right recursive call for the 2. So for the 2, the right recursive call goes, and in that particular I am passing 2 to right, this particular one. And what is the 2 to right? That is the 4. So I am passing a root as a current root as a 4. So what is my first step in case of a preorder traversal? Whatever the value of a root, I will simply add it to the traversal. So let us add 4 in the traversal. After that I will make a left recursive call. In the left recursive call I am passing 4 to left. There is nothing in the 4 to left. So what will happen is I will simply come back to 4. So I can say that when here is a call goes, I got a null, and simply I come back to this 4, because there is a base condition. Whenever I am getting a root as a null, I will simply return to the previous stack frame. Again there is a right recursion call will goes here. In the right of the 4 I will again get a null. So when again I get here null, what I will do, I will simply return back to here. So again there is a condition hits that if root is equals to null, simply come back. So here it will come back. So if you carefully see, for this particular 2, I have completed the left recursion call as well as I have completed the right recursion call. What I need to do now is I have to do this overall function for the 2 is done. So basically the control comes back here. Now if you carefully see, for the 1 we have completed this particular left recursion call. Let me erase this all. So I can say that for this one we have completed the left recursion calls. What I will do now is I will make a right recursion call, that is I can say, let me explain. Now for this one, this part will execute first and then this part will execute first. So first of all, the recursive call goes to 1 to right, which is nothing but a 3. So the function is called for a 3. So f3. So what is the current root now? The current root is a 3. It is not a null. So base condition which doesn't exist or does not hits. So basically the function is called for a 3. So let me write it separate after some distance. So I can write it like this. So function is called for a 3. So when the function is called for a 3, what I will do is whatever the value other than null, I will simply add it to the answer. So let us write here 3, and what I will do is now I will make a left recursive call for the 3. I will make this particular recursive call in the left. So what is in the left of a 3? There is nothing present in the left of a 3. So can I say that I have to return from here? Whenever I am going to the left of a 3, I got a null. So basically I will simply return to here. Clear? So when the recursion call goes to the 3 to left, I got a nothing, and I come back to here, if you carefully see, and the left call for the 3 is completed. Now what I will do is I will make the right recursion call to the 3. So let us make the right recursion call to the 3. In the right, what is in the right of a 3? I have a 6. So here right recursion call will be for the 6. So whatever the non-null value is present, whatever the value is present other than null, I will simply, as a current root, I will simply add it to the traversal. So let us add 6 to the traversal. After adding it to the traversal, what I will do, again for the 6, for each and every node, I am making it 2 recursive calls. If I explain you with the example, let me explain. If you carefully see, if you carefully see, for each and every node, I am making what? I am making a left recursive call and I am making a right recursive call. Here, for each and every node, I am first of all taking out the root, and then I am making a left recursive call for that particular root, and then I am making a right recursive call for that particular root. And so recursively I am doing this stuff. So this is how I am doing. First I go to the 1. After going to the 1, I am taking a 1, and then I am making a left recursive call to the 1. Then the current root is the 2. Then I add 2 to the answer, and then I am making a left recursion call to the 2's to left, and then taking a 5 as a current root, and then making a left recursive call to the 5 to left. Here's nothing is present, so base condition is that one. When the root is equals to null, then I simply need to return. So basically return here, and this is how these whole things will works. So I am at this particular one. Let me explain it clearly. See, so after that, if you carefully see, I am at the 6. So 6 is my current root. Now I need to make the left recursion call for each and every node. Here I will get a null, and simply I will return here. And then again I will need to move the right recursive call. So there is no space, so I am writing here. So there is nothing in the left, right. So I will simply return back here, and after all these things, I will come back to the exit point of my program, and you can see the traversal is out if you carefully see. So let me quickly explain what we have done in this whole stuff. So let me erase all these things. So make sure you have subscribed our channel. I am making a videos. This is a hard working task for me, and I'm thinking about to upload a videos on a C++ course, complete course for the beginners also. So let us see. So see here, if you carefully see, what we are doing is we are making a basically first of all we are calling this function for a 1. I taken a 1 in the traversal. Then for each and every node I have made 2 recursive calls. What are these 2 recursive calls are? First recursive call is this, and the second recursive call is this. The first recursive call goes to the left, the second recursive call goes to the right, and recursively for each and every node I am doing stuff, and finally whenever I get a root is equals to null, then I will simply need to return. So I hope you understand the concept of how this thing works. And for the 1 I am calling recursively for its left, that is the 2, and again for the 2 I am calling recursively for its left, that is the 5, and again for the 5 I am recursively calling left and right, and so on the things happens. And this is a recursion tree. I hope you understand the concept. So this is how whole things works. This is the overall code for the basically the pre-order traversal. And also one important thing is that here if you see, this root is nothing but this root is a this root is a starting. In the starting, when I'm calling a function, I will pass the starting address, means root node address of my tree. So I have also discussed the code how to create. So make sure you subscribe our channel if you understand this concept little bit. So let me know in the comments, and if you don't understand anything, also let me know in the comments. So see you next video. Till then, bye bye.